fair number of definitions in this unit. Independent events. Two events are independent if one does not affect the other. Right? For example, let's say by chance I was flipping a coin and I got heads 5 times in a row. Will that affect my chances of rolling a 2 if I roll a dice? No. Those events that happened before don't affect the chance that's happening next. In fact, it's one of the things that people get confused on for flipping a coin. If a coin is fair, it's 50-50. It is possible to flip it and get 5 heads in a row. Does that mean the next time you have a better chance of getting tails because you haven't got it yet? No. The next time your probability is still 50% because those are independent. But it feels like it should become tails eventually, and it probably should. If you're planning on buying lottery tickets and winning the lottery, practice winning first by, like, it's easier to flip a coin and get, I think it's almost 21 or 22 heads in a row is equivalent to picking the right number to win the lottery. So if you think you're ready to win the lottery, start flipping coins. And once you get 22 heads in a row, go out and buy a ticket. What are your chances of doing that? Very, very unlikely. Don't start, because you might be flipping coins for the rest of your life, and then that's not good. You make less money doing that than flipping burgers. Okay. So when a dice is rolled and a coin is tossed, these events would be independent because what happens on one doesn't affect what's happening on the other. Now, there's a probability formula for independent events. It's called the product rule. And the product rule says probability of A and B is equal to the probability of A times the probability of B. But that only happens and only works if they're independent. Card is randomly chosen from a deck of 52 cards, and a fair 6-sided dice is thrown once. Find the probability the card is a jack of spades and a 5 is thrown. So we want the probability of the jack of spades and a 5. Since these are independent, they are not affecting each other, getting the jack of spades, 1 out of 52. Rolling a 5, 1 out of 6. For a probability of 1 out of 312. Red, since these are independent, first red one is 3 out of 5, the second red one is 1 out of 5. Probability will be 3 out of 25. The marbles are different colors. Now we have to be careful here because you could get, there's 2 cases. You could get red and white, or you could get white and red. Does that make sense? Now if you got the red and then the white, it would be 3 out of 5 times 4 out of 5. Red from the first one, white from the second one, 12 out of 25. White and then red would be 2 out of 5 and 1 out of 5, which is another 2 out of 25. Since those are 2 separate cases, we add them up, and our probability will be 14 out of 25 to get marbles of different colors. At least one marble is white. Can you see that that would be exactly what we have in B plus one other case? The other case is getting both of them white. And both of them white would be 2 out of 5 times 4 out of 5, which is 8 out of 25. Add that to the 14 out of 25 that we had before, and you would get 22 out of the 25. So I took the 14 out of 25 from part B, because those have one white one, plus the 8 out of 25, because I figured out both of them being white. And then I have the idea of at least one marble is white. And this one is a new spelling of one. It had a, there we go. How's that? That's a little bit better. At least on marble is white. Now, that's one way of thinking of it. Now, the other thing I want you to realize is when you see the word at least, it's often easier to think of the opposite. So if at least one marble is white, what's the opposite of at least one marble being white? Both of them being red. So the complement is both of them being red, and if you had done 1 minus the probability of both of them being red, 1 minus the 3 out of 25, get a common denominator, you're going to get 22 out of 25 that way as well. Now, in the situation that we had here, because we'd already done A and we'd already done B, both seem to be about the same amount of work. If you were only given part C as the question, I think this that we did here in black would be a little bit quicker, because there's less things to figure out. This one you had to figure 1, 2, 3 things to add them up, 3 different cases. Here you just had to figure out one thing and subtract it from one. That might have been a little bit quicker. Okay, another one for you to try. So there is a lattice diagram. We want event A to be the sum of the two dice is 6. So I'm going to circle that. Event A I've circled in red. And event B, the number on both dice is the same. So I'm going to circle that in purple. There we have the 3 circles there. So we want to find the probability of getting the sum of the two dice is 6 and the number on both dice is the same. Can you see that there's only one of those where it's both? And so our probability is going to equal 1 out of 16. It's just that one that's been circled twice. Because the probability of A and B, they both have to happen, and that happens only once. The probability of A or B, 1, 2, 3, 4, 5, 6 of them out of the 16 are A or B. Notice I didn't need to use any formula. We could have done the probability of A being 4 out of 16, A being 3 out of 16 plus the probability of B 4 out of 16, and then subtracting the 1 out of 16, that was the overlap. But we could also just count it since we've done a diagram that way as well. Are the events mutually exclusive? Are they independent, or are they neither? Well, mutually exclusive means that they don't overlap, right? So we could explain it from the fact that if it's mutually exclusive, what does that mean? If they're mutually exclusive, probability of A and B equals 0, but probability of A and B equals 1 out of 16. So they're not mutually exclusive. So we use what the formula says mutually exclusive is, and we check the math in that situation. And since it doesn't work, they're not mutually exclusive. For independent, if they're independent, then we know that the probability of A and B is equal to the probability of A times the probability of B. Well, we already figured out that the probability of A and B from above was 6 out of 16. No, 1 out of 16, right? Sorry. Probability of A and B was 1 out of 16. If we take the probability of A and times it by the probability of B, well, the probability of A was getting 6. Wow. Yeah, A is 6. That one was 3 out of 16. And B was getting the same number, which is 4 out of 16. Multiply those together, and what do you get? 3 out of 64, or 12 out of 256. Is 3 out of 64 equal to 1 out of 16? No, so they are not independent either. So they're neither mutually exclusive nor independent. Again, there's some more probability questions there.